Hello, this is Bill checking in with Paul McWhorters PicoW class homework and lesson number 20. And this deals with a DTH sensor to display humidity and temperature. And the assignment was to do a toggle switch, which we've done several times. But you toggle the switch to display degrees Fahrenheit and degrees centigrade, so the scale changes on that. And this is kind of how I went about it. You can see I did the sensor on one side of the board and the buttons on the other side of the board. And you can see right here, this goes to number 16. This is number 15 that goes to read the sensor. This sensor, I had a little trouble with it. I tried setting it up before the lesson and wasn't doing very well. Got online and I thought I had everything set up correctly, but anyways, I didn't worry about it a whole heck of a lot because I knew I was going to listen to the lecture. Anyway, we had done this before in the Arduino class, so I looked that up and pulled out my Arduino, dusted it off, and tried it, and I couldn't get it to work on the Arduino either. And so this particular sensor that you see here is actually the one that came with the Arduino, and it's a three-leg sensor instead of the four-legged sensor, so I had to change that a little bit and hooking it up. I don't know how well this is going to show up there, but there's only three legs, and the one to the farthest to the left is, let's do it this way. The one farthest to the left is actually the sensor read thing, and I hooked that up to number 16. And then the middle one is the power, the 3.3 volts, and then the one on the right hand side is the ground. So that's how I hooked this up, and we'll get that set up. This isn't real exciting to see. We don't have lights or anything. But anyways, and then I listened to Paul's lecture, and I tried to hook it up again. The three-legged sensor worked, like I say, on Arduino. I couldn't get the four-legged one to work at all. Listened to Paul's lecture, went through the whole thing, certainly made the appropriate changes for, which was the correct leg to hook up and read from. And boy, I just couldn't get that four-legged one to work. It doesn't have anything labeled on there, and so kind of as a goofy last-ditch effort, I flipped it around. So instead of looking at the front, I was looking at the back, so right is left and left is right. And I give you a pro tip. If you decide to do that, you want to get your camera ready, because it's unbelievable how fast that thing melted. So anyways, I tossed it. I was sure it wasn't going to work after that. And I actually ordered a four-legged one from Amazon. But for the assignment, this worked, and it's still the same thing. So anyways, we'll go from there. Let's look at the code. From machine, import pin. From time, import sleep as ZZZ, which is kind of a Charlotte thing. From DHT, import DHT11, and there are other ones besides the 11s that I saw when I was looking on Amazon for a replacement. the delay, I did 1 second, and I'll get into that a little bit later when we try it out, but if I went below a second, I would get errors on the sensor. I don't know if the four-legged sensor is faster, but whatever. Anyways, that's the way it worked on this particular one. Then I set up the DHT pin as number 16, which I mentioned before. I need to read up. I think Paul explained it in a little more detail with this pull-up, pull-down stuff in the Arduino classes, and I should probably revisit that because I'm just putting it in there because, and I don't think I have a solid understanding of what's really going on with that. But anyways, we did the DHT setup. So that was pin, and we're calling up this variable, that's 16. We go pin dot out and pin dot pull down. Then the DHT sensor is DHT11 and DHT setup. So that's what we're going to use to call the sensor to read from it. The button pin, like I said, was 15, and the kind of the usual suspects here, we have to pick a state for whether the button is being pushed or not being pushed. And the same thing with, instead of an LED, I'm calling this temp scale, because the scale is either going to be Fahrenheit or Celsius. Excuse me. And the same deal. We have, the button is the button pin, so that's variable for 15. Then pin in, comma, pin dot pull up, and I guess this saves us from having to get another resistor 10 ohm or whatever it is for that. And like I said, the temp scale is either true or false on or Fahrenheit or centigrade. And then we printed it just so this would always stay in place, so it's above the while true. I printed temperature, gave some space and humidity, and I kind of dinked with that to make it look nice when it's being printed. Now we get down to the while true. Button state equals button value, and that is to read where the button currently is. The DHT sensor dot measure, that calls up the DHT sensor, and then temp C equals DHT sensor dot temperature, and you got to put those parentheses around there. And so that'll call up the temperature. Humidity is the DHT sensor dot humidity, and that calls up what the humidity is, and we're signing the variables temp C and HUM for humidity. Then we're getting down into the toggle portion here. If button state equals 0 and old button state equals 1, temperature scale equals not temperature scale. So essentially what we're doing is we're checking to see if the button is pressed or not pressed, and if it has been pressed, we are switching the temperature scale from true to false, or more appropriately centigrade to Fahrenheit. And then we reset the button. Old button state equals button state. And then depending on if the temp scale is true or false, it prints two different things. There's kind of some goofiness in here that's nice, that makes things look better, but I have print, and we have this \R, and that is to stop the scrolling, and I guess that needs to be coupled at the end of this with end equals, and then you just put a space. And then I have some spacing in here to make it line up with temperature and sensor. The CHR parentheses 176 is a code that calls up the little degree symbol, which I thought was cool. I never knew how to do that. And then we concatenate, I guess, or tack it on, I guess is another way of saying it, with the letter C. So that tells us that it's centigrade. And then, so that's, if it's true, it'll print this. If it's false or Fahrenheit, it'll print another one. And what I did was I just took the temperature C and did this formula. Why does this thing always turn off on me here? And so what I ended up doing for that is I did centigrade as being X, Fahrenheit as being Y. I did boiling and freezing points. So I said centigrade's 100 when Fahrenheit is 212. Centigrade is 0 when Fahrenheit is 32. Draw it like that. I don't know why I do. It just makes it easier for me. And so the slope is 212 minus 32, rise over run. So the height of it is 180, and then the run portion of it is 100 minus 0. That comes out to be 180 over 100. That reduces down to 5/9. Then our point slope line that Paul likes is y minus y1, or y is actually centigrade, or I'm sorry, Fahrenheit, and x is centigrade. So we plug in the slope, y minus y1 equals 5/9 x minus x1. I plug in the freezing point there, so y minus 32 equals 5/9 x, or Fahrenheit, minus 0, do the math, y, or I should say centigrade, equals 5/9 f times Fahrenheit times 32. We'll get that back looking at this thing. And then I put in a delay like I mentioned earlier. If I did anything less than a second, the sensor would error out. So the toggle switch isn't too speedy. I don't know if I've got this thing running or not. We'll take a look here. I've got temperature 23C, and the humidity's 23%. It's been raining here a lot, so so anyways, 23 and 23, and those are actually two different readings. It's just they happen to be the same. Now we'll click on that, and the temperature you can see toggled over to 73.4, and the humidity is 23. And this brings up something. I'm sure there's a way to limit the number of places past the decimal. I'm sure there's some kind of code when you print. If somebody knows that, great, because you can see it kind of goofs up the symmetry in the way that reads. Oops, that fell down. Do it this side. You can see that works out better. Oh, and you can see it also goof that up. With the humidity, it's still got the remnant of the 23 from the last go around. I can toggle it again. You can see we get rid of it. Toggle it again, it comes back. So If there's a way to limit the length of the float, that would be great. Um, Anyways, that's it for now. See you guys on Tuesday. Bye-bye.